similar shapes in 2D and 3D. These types of questions rely on, first of all, finding out how much larger your bigger shape is than your smaller shape. Now on these two shapes, I'm giving a little bit of a clue here, and that clue is the bottom dimension. It means I've got information about one particular dimension on both shapes, and that particular dimension here is that this is worth 3, we'll assume it's centimetres, and this is worth 7.5. We'll write the centimetres in there to make it all neat. So this dimension 3 centimetres, that dimension 7.5 centimetres. From that information alone, as we've got information on the same side on both shapes, we can actually work out how much larger this shape will be than the smaller shape. So to do that, we see how many times does 3 go into 7.5. So we do a quick sum here. So 7.5 divided by 3 means 2.5. So in other words, this larger block is going to be 2.5 times bigger than the smaller block. So what we're going to do, we're going to put that in the table here. So in other words, for every 1 centimetre in the small block, we're going to have 2.5 centimetres in the large block. Right, that's to do with length. Now we've got to consider the effect of what happens to the area when the length is multiplied by 2.5. Well, the effect that has on the area will be squared, because remember we use centimetres squared or metres squared as a unit for area. So the effect on the area would be that for every 1 centimetre squared of area, it will be 2.5 squared for the larger shape. So in other words, 1 centimetre squared of area on the smaller shape represents 6.25 centimetres squared on the larger shape. You might be asked then in a question, once you've worked out the linkage of how much bigger the larger shape is than the smaller shape, in this case 2.5, you might be asked, well, if the area of this face on the larger shape is 187.5 centimetres squared, what would the corresponding area of the face on the smaller shape be? So you wouldn't divide it by 2.5, you divide it by the 2.5 squared, which is 6.25. You put that in a calculator or in your head if you're feeling particularly energetic. So it's 187.5 divided by 6.25, and that gives an answer of 30 centimetres squared. All right, so the final thing that they might ask you to do would be to compare the volumes. Now, we're given some information here now that the volume is 200 centimetres cubed. You don't go and multiply the 200 by 2.5 to find the volume on the bigger one. What you do now, we go back to our table. It's going to be 1 for every 1 centimetres cubed volume in the smaller shape. It's going to be 2.5 cubed centimetres cubed on the larger shape. So let's work that one out. So it's going to be 1, so it's going to be 2.5 cubed. Where's my cube button here? Which is going to be 1 to 15.625. Okay, so for every 1 centimetre cubed on the smaller shape, we're going to have 15.625 centimetres cubed on the larger shape. So our volume for this one is going to be, the volume is going to be 200, which is that 200 there, multiplied by our volume factor, which is 15.625. So times that by 200 then, and that gives us 3,125 centimetres cubed. So that's how you'd work out the volume of the larger shape given the 200. Okay, so a summary of that little table there is, first of all, we found out how much bigger the big shape was than the smaller shape by looking for the common side. Here we had a 3 and a 7.5. That gave us our magic 2.5. That was very good for length. When it came for area, remember we had to square that dimension. So for every 1 centimetre squared was 6.25 centimetres squared. And finally for volume, you have to cube the dimension there. So 2.5 cubed give you 15.625. Little extension here. If we've been given areas rather than lengths, we've got to work out how much larger the shape is in length. So my small triangle is 2 centimetres squared, and the area of my large triangle is 32 centimetres squared. So my area ratio is going to be 2 to 32. Let's go and get the red pen over here. So 2 to 32, which is actually 1 to 16. So remember this is an area. 16 though, remember this relationship is squared. What number do you have to square to make 16? Otherwise we're going to find a square root. In other words, 4 squared. So our area ratio is 1 to 16, or 1 to 4 squared. So that means then that our length ratio would be 1 to 4. And then finally, we're back to square one now. We can use our volume ratio of 1 to 4 squared. 4 cubed, sorry, for volume, 4 cubed. So that's going to be 1 to 64. So that's another angle they could approach a question for by giving you the area ratio instead of the length ratio to start with. So be careful of that one should it come up. So there we have it. We've got areas of and volumes of similar shapes, 2D and 3D.